Hello, amazing and interesting viewers. Thank you for stopping by. And this one's take a look at reading function values from level curves. Okay, so here's a 2D depiction at first. Let's begin with that. Okay, what we want to know is, for example, the function value at some point between the level curves. Let's zoom in here. Let's say we focus on where? Like this point right here. Now, if you look there, this is 0.6 and this is 0.8. Now, the surface is continuous. That means it's unbroken. There are no holes or jumps or gaps, anything weird. Which means that this stands to reason that this should be 0.7 in this location. There you go. So let me maybe fold that in a little bit like that. Let's go on to a different location somewhere else. Okay, let's see. Let's move on to say here. Okay, so what's going on here? Now, notice back here, let me point to it. Okay, this is the 0.8 level curve, which means if you follow this curve this way, all the way to here, then this is still the 0.8 level curve. So maybe I should begin by labeling this as 0.8 here. That's that level curve, which means if you want to pick out a function value between the curves, just, again, the surface is continuous, unbroken, so this is 0.9 in this location. Make sense? Let's go maybe over here. So now this is the level curve 0.4. This is the level curve 0.2. The surface is unbroken, continuous. So that means here you have 0.3 as your function value, roughly in the middle between them. Now let's take a look at a 3D depiction of the same thing. That's important too, to relate level curves to function values in 3D. Okay, so look at this. It looks like a hill when you actually graph it and look at it in three-dimensional space. So here, since this is, look at it, 0.8, and this is 0.6, and as you can see, the surface is unbroken from 0.6 to 0.8 over here along this line. And it makes sense that you see here you would find 0.7 in this location, so 0.7 right there. Okay, but really also remember we're talking ultimately about the z-axis. So when we say 0.6, what we really mean is 0.6 along z. We really mean 0.8 along z, and here we mean 0.7 along z, like that. And then you repeat the similar reasoning for other points on the surface. One thing else that I want to talk about today is, just as a reminder, when you move along a single level curve, it represents constant function values. So what I mean is, let me just pick out one of these and trace over it. I'll do 0.4, right? So if you move along 0.4 this way, right, here the entire time it's the same value for the function, like this. Okay, always 0.4 regardless of where you are located on this curve. Okay, so I'll trace the whole thing. It doesn't matter where you are, it's always 0.4. Like this, okay, like this, all the way around, it's 0.4. 0.4, there you go. So while we may give you only a single value like 0.4, you gotta really understand, right? It's 0.4 here, okay, it's 0.4 here. Anywhere you go. So this is 0.4, okay, this is 0.4, all the way around it's 0.4. And in three-dimensional space, what this of course means is the following. Let's move into that part now. We're talking about this curve here. You see, you're traveling this way along the surface, so that means you're always 0.4 units, in this case above the xy plane. Always 0.4 units above the xy plane, like this. Because if you look over to here, this is always 0.4. And that means you're the same height above the xy plane at any point on this level curve. So I hope this is helpful. Please be sure to like and share and check out other videos on this channel. My name is Tom. I'm a college instructor. Thank you for being an interesting person who's into stuff like this.